When people start with Arduino, different people struggle with different things. In my case, I had really hard time working with individually addressable LEDs. And they were one of the reasons I even discovered Arduino, because I was so eager to do some projects involving LED strips. In this video, I'm going to provide you some tips that hopefully are going to help you not to fall into those same pitfalls I did. And your future LED projects would be more like that. Stick around. When I purchased my first individually addressable LED strip, I thought I have everything figured out. It was clear to me that I will be using RGB color model. In this concept, all colors are created from the combination of red, green and blue colors. In this model, each color, or should I say the amount of that color in the mix, is represented by 8-bit value, which translates to integer value ranging from 0 to 255. This allows us to address, let me think, 255 times 255 times 255 colors. That gives a staggering number of over 16 million. To enable RGB data model in Arduino code, we would work with CRGB data class, which represents each pixel or LED with combination of 3 bytes. 1 byte representing red, 1 representing green, and 1 representing blue. In this example, let's look at the representation of color pink. We see a hex number which can be divided into 3 bytes. Here are the decimal representation of each byte. Before we start looking at how to use CRGB data class in Arduino code to control LED strips, let's look at what do we need to start writing such code. We would be using FastLED library. It can be downloaded from GitHub and installed in Arduino IDE. If you do not know how to do it, please refer to this video. I usually use following type of individually addressable LEDs, either in the shape of LED strip or LED matrix. The great thing about FastLED library is that it allows to declare a range of different LED types. And when you do it, then you control these different LED types with the same commands, making it really easy and transparent. You declare a number of attributes of the LED strip first, like data pin, through which we control the state of all the LEDs in the strip. For certain LED strips, you also need to declare the clock pin. Then also you need to specify how many LEDs your strip consists of. You also need to declare a table of CRGB type objects. The size of the table is equal to the number of LEDs in a strip, and each cell of that table contains 3 bytes representing RGB values of the corresponding LED. Then we declare the LED strip and link it to the table we just created. This declaration is for WS2812 strip. That does not require clock pin. RGB attribute represents color order. This particular attribute also cost me a lot of headache, but I will get to that. The second declaration is for WS2801, and in this case, clock pin is necessary. So we have our LED table definition, and we have our LED strip. What do we have to do to lit the first LED in the strip and make it pink? Here is the reminder of the 3 byte representing RGB for that color. We can light the first LED pink in 4 different ways. The first one is to use CRGB method, which will return desired 3 byte combination and assign it to the first cell of the table. In the second one, you can assign decimal values corresponding to red, green and blue to appropriate attributes of the CRGB object representing the first LED. Third one is to assign hex representation of the 3 bytes directly to the first cell of the LED table. And the fourth one is to use the predefined color definition. You can find a large number of predefined colors. This way, you don't even have to be aware of underlying RGB values. Whichever way you choose to set the color of the LED, you need to execute FastLED show command before the changes are reflected on the strip. This will update the state of the LED strip, and the first LED would light up and it would be pink. FastLED show command redisplays all LEDs according to their current state. To demonstrate how this works, I want to create a control panel from which I would be able to control this 8x8 LED matrix which is nothing more than a strip of 64 WS2812 LEDs. We will need Arduino Nano, 3 potentiometers, one for every color component. We connect those potentiometers to ground and VCC, and also to analog pins A0, A1 and A2. Then we connect LED strip, or in our case LED matrix. Again, we need to connect it to ground and VCC, and the data pin goes to digital pin 13. I will also need the small OLED display, where I can track the current values of each color component. Again, ground and VCC connection is needed, and then, since the OLED display is the I2C device, we need to connect it to I2C pins A4 and A5. Finally, I will need one more potentiometer. I will explain later what I plan to use it for. It will go to analog pin A3. To mount all the components, I printed this panel. I will use those 2 mini breadboards and then connect all components as per diagram. Let's go through the key parts of the code. Link to the complete sketch can be found in the description below. We need variables to represent 3 primary colors. In setup, we have declaration of LED strip with RGB color order. In loop, we want to associate the values read at the potentiometer pins with values linked to 3 primary colors. Range read at the pin is from 0 to 1023, and the primary colors are represented by values from 0 to 255. We use the map function to map one range to the other. Here you have the code that does just that, and you can see the source and target range. We set all 64 LEDs to the color that is defined by red, green, blue values, and then run FastLED command to update the LED strip. Let's load the code to Arduino and see if our color selection panel works. We can change the value corresponding to primary colors by turning potentiometers. The current values of red, green and blue are displayed on the screen. Let's try to display one of the predefined colors called deep pink. I set the listed values for red, green and blue, and that does not look like pink. There is something wrong. Let's try to see if primary colors would work. And they don't. That color should be red, and it is green. So the LEDs I'm working with have a different color order. I did not realize that even with the same model of LED strip coming from 2 different manufacturers, wiring and thus color order may be different. If your LED strip has a different color order than RGB, you need to calibrate it first to properly control it with the methods provided by FastLED library. With FastLED library come a number of example programs. One of them is programmed to calibrate the LED strip. Let's open it and quickly go through it. This is an easy piece of code, but quite smart. We declare FastLED library first, then we specify the number of LEDs to control. Next we declare data pin. Let's adjust it to digital pin 13, which we use in our setup. We do not need clock pin for our type of LED strip. We also have to declare the table representing LED matrix. Then we have the list of all possible LED strip declarations. Let's find our type, which is WS2812, and uncomment it. In the declaration, we use RGB color order. In the loop function, assuming the color order is okay, we are attempting to lit the first LED red, next 2 LEDs green, and the next 3 LEDs blue. It will work if the color ordering is properly defined. Let's compile our code and see. And it is not. We see the first LED lit green, then 2 red LEDs, and finally 3 blue ones. The number of LEDs lit in each color indicate its position in the color order. So in our case it will be green first, then red, and then blue. Let's swap red and green symbols in the color order around. Then adjust LED strip declaration. I am reflecting this change in the code and reloading it to Arduino. Excellent! You can see that with that change, LED strip is calibrated and showing proper color order. I can now adjust the color order in my setup and see if potentiometers control the colors in the proper way. It works now. I can properly display each primary color. Let's again try to display deep pink predefined color. Now it works great. So my first problem with LED strips is now resolved. The second issue I had is that with millions of colors at hand, it is really difficult to select nicely saturated colors for my projects. 16 million colors would be great for e.g. TV screen, but for LED Arduino project, it is an overkill. Turning potentiometers, I am changing the colors, but a lot of them are either pale or seem nearly identical to the other ones I have seen or selected before. But RGB is not the only color model out there. There are different ones that may be an answer to my color selection dilemma. Let's look at the HSV color model. Just like in RGB color model, we also have 3 axes representing each pixel or LED. The first one represents the color, the hue, the angle around the color wheel. The second represents the saturation, and the third one represents the brightness. So with changing the hue from 0 to 255, we go through smaller number of nice distinct colors of the rainbow color space, which is just what I need for my LED projects. We also have CHSV method. Here, just like for CRGB, each pixel LED is represented by 3 bytes. First representing the hue, second representing saturation, and third representing brightness. And here also we have alternative syntaxes we may use to set any given LED to desired color. Let's take blue color as an example. We can use CHSV method, or setHSV, or setHue method. SetHue always assumes full saturation and full brightness. So let's write the code that will have LEDs lit with CRGB method and LEDs lit with CHSV method side by side. I'm adding one more variable to represent value read at the 4th potentiometer. In setup we declare LED strip with updated color order. In loop we display RGB LEDs to the right and HSV LEDs to the left. I printed a dedicated diffusion panel, which clearly indicates which LEDs are which. Let's load the code and see how this works. The LEDs are lit, and on the left you have the ones lit with CHSV method using colors from rainbow color space. The LEDs are very bright, so let's use our diffusion panel. I am turning RGB potentiometers, and you can see that color changes are not really spectacular. Now let's do the same for HSV side. You immediately see the difference. All colors are nicely saturated. Those 255 colors are all you need for your LED strip projects. With HSV you can also achieve nice color transitions. You'd have real difficulties doing the same thing with RGB color model. Another problem I had was controlling brightness of individual LEDs rather than all LEDs in the controlled strip. When using RGB, it is possible when working with primary colors. Let's take red as an example. This command would lit up the first LED in the strip red with full brightness. When we want it to be half as bright, we just change the value representing red color to 128. But I cannot do the same, for instance, for pink color. I dare you to tell me what values should I enter here for CRGB method. Not straightforward, right? We can use FastLED set brightness. It will work, but it will affect not just the first LED, but all LEDs in the strip. With HSV, it is so much simpler. Here is a command to display first LED red at full brightness and then at half brightness. The third byte controls the brightness of LEDs, so there is no problem to perform the same action for pink color or any other color from a rainbow color space for that matter. That pretty much wraps up this video. Hope you will find it useful. As always, like, share and subscribe. Do you know that you can become my patron? I still have just one patron, and I would hope that with thousands of people watching my videos every month, I would have at least two. I will see you in my next video. Bye.